Hooray, hello everyone. It's time for another science news stream. And I think I'm gonna do this one a little bit differently this time. I think what would be perhaps a bit more... I don't know if entertaining is necessarily the word, but I think I realized lately that reading through articles and stuff, it's a little bit more interesting diving into the deeper details of things. To give some context, I read, we're not doing this article today, but I read an article basically talking about long COVID stuff and how... So I read one thing talking about how we had found the reason for long COVID. Hello, killer. And then I looked in the articles because I'm like, okay, like, yeah, let's see what they got. But the article actually didn't say anything about the reasoning behind it, or at least not so explicitly. So I was like, okay, and it was more of a article about what can be done to help alleviate some symptoms, which is good. But then I started to look into even like the techniques they showed, and even then it was kind of a case study deal, so there were only like 3 people they did this on. And then I was like, I don't even know if this is like really reproducible or not, just based on a few different factors in this. And then I looked into other things like the conflicts of interest of that paper, and it basically showed like, oh, these people have conflicts of interest because they're high ups in this company or whatever. And then I looked into the company and I was like, oh, that company is partnered with another company of which one technique they use. So I was like, so is this just to like, is this just to advertise company 2's like genetic techniques and stuff, or what? Like, it was like, so what was this paper even put out for? Like, what was the specific reasoning behind it? So I think I want to do that more. I think, because to me, that was like a fun process of just doing basically surface level diving behind an article and the paper behind it. So I think we're going to do that today. And today, we're talking about this article saying that scientists prove fish suffer intense pain. I feel like I haven't kept up with the fish feel pain debate, but a lot of times I usually hear like, no, they don't actually have the brain power to actually have the capacity to feel pain. But then other things are like, I don't know, they sure seem to move around a lot when they have a hook stabbed into them. So I think what we'll do is we will cover this article, and then I have the paper behind it, and we'll deep dive into the small nitty-gritty details. And then we'll kind of see if there's any other things along the way that we can learn, or things that we want to delve into. And I think at least this way, it's one topic, it's easier to comprehend. And I'm also going to do a little fun thing where I'm actually going to start keeping little points on the screen of like, hey, here's what we talked about so far. That way, if anyone does come in, then it's not like, oh, well, I have no clue what the hell's happening or what's going on. And they can be like, oh, okay, so here's what's been like covered so far, or what's been talked about. Make it a little bit here. Let's just change that font a bit. That way, easier to comprehend, not as daunting or as scary to be like, hi, can you explain to me everything that's been going on up to this point? And hopefully a bit easier to stomach for most people. You know what? But now I'm just being nitpicky about font. Okay. That's probably fine. So we'll close that for now. Alright. So let's get into it. Scientists prove fish suffer intense pain for at least 10 minutes after catch. Calls made for reforms. Hold on, let me make sure I have this up so that I can see that. Okay. So let's see. Each year, more than 2 trillion wild and farm fish are killed to feed humanity. Their deaths often go unnoticed. Yet beneath the surface is a simple biological fact. Fish can suffer. Rainbow trout, the species, and granted this topic is already a little bit like, okay, like, are we saying all fish? Are we, is every marine life organism included under that? Or did we just look at rainbow trout? So the questions you kind of got to ask when reading through something scientifically and going through data, it is so important to be like, okay, what are the specifics here? So let's see. Rainbow trout, a species farmed and consumed across the globe, experience not just death, but a prolonged and intense form of distress when killed by air asphyxiation. Damn. A new study published in the journal Scientific Reports shines a light on this pain and offers a pathway to reduce it. Fish pain needs better measurement. True, because I was also going to say, how are we quantifying these fish feel pain? How do we exactly measure that? Unlike environmental impact or public health, animal suffering lacks a universal metric. Does this article go into, let's see, immediate ban on boiling crabs and lobsters called for? Let's see, do we have any kind of metric, or is this, oh my god. Oh, interesting. Okay. So they have electrodes to measure the brain activity and then subjected them to mechanical and chemical stimuli. Okay. So we just basically have the full-on, like, we're gonna probe your brain is what this is. Applied a potentially painful chemical form of vinegar. Damn. And they just poured vinegar on the bastard. Anyways, let's keep on what we're on. We'll get to that later if we want to. So let's see. There are no equivalents to carbon footprints or life years lost. To address this, scientists developed the Welfare Footprint Framework, or the WFF. This tool measures pain in minutes, allowing researchers to compare welfare outcomes across species and conditions. The research team applied this method to trout slaughter, where air exposure is still a widely used technique. Fish, when pulled from water, begin a slow and stressful decline. Their gills collapse, they gasp in panic, their blood chemistry spirals, oxygen disappears while carbon dioxide builds. These biological reactions unfold as the fish continues to move, gasp, and suffer, sometimes for as long as 25 minutes. The researchers divided the trout suffering into 4 time segments. These range from alarm at removal to the final depression of brain activity before unconsciousness. Through behavioral, neurological, and pharmacological evidence, the team estimated that the average trout endures about 10 minutes of pain that qualifies as hurtful, disabling, or excruciating. In some conditions, this could stretch beyond 20 minutes. When adjusted by weight, that translates to 24 minutes of such pain per kilogram, about 11 minutes per pound of fish killed. Okay, I thought we were talking like for one fish. Wait. So we're quantifying like for this many pounds of fish, this many minutes of pain are being produced. Interesting, but I guess gotta have something to measure. Okay. So the team used neurophysiological data like EEG signals and reflex loss to identify consciousness. I'm gonna assume this is for brain signals. EEG. Electrical patterns produced by brain. I want to use the AI overview if I can help it. Let's see. Implying recording spontaneous biological potential of the brain on the scalp. Yeah. Okay. They reviewed how fish respond to CO2, pH imbalance, muscle exhaustion, and fear-inducing stimuli. Each pain level had specific criteria ranging from annoyance to total disruption of basic functions. This fish got really mad It got really annoyed that this was happening. Air asphyxiation is still legal and common in many parts of the world, but it is neither quick nor painless. Chilling in ice or using ice slurry might sound gentler, yet for cold-adapted species like trout, this method just slows down metabolism. This can delay loss of consciousness even further, compounding the suffering. Ice exposure also risks tissue damage, thermal shock, and prolonged fear. The research shows that suffering does not always begin at the point of slaughter. It often starts well before. Crowding, transport, and handling all add to the fish's cumulative pain. Why? Okay, I was like, why do we have a single, like, highlighted link to an article for fish? Fish thought extinct for 85 years reappears in Himalayan river. Actually, why do we have that article? Hold on. No, I gotta take a little quick look. Okay, freshwater species still under threat. Continuing exploration. Snakehead conservation. Okay, so we just linked to another article, I guess. Sure, why not? I guess, well, okay. Anyways, whatever. These pre-slaughter stressors can cause physical injury and hours of distress, yet regulations usually overlook them. Which, granted, I don't really know what the regulations on fishing currently are, as far as, like, minimizing fish suffering. The study evaluated 2 types of stunning, electrical and percussive. So you got smacked the fuck out of it. Electrical stunning, if properly used, could spare 60 to 1,200 minutes of suffering for every dollar spent. This makes it one of the most cost-effective welfare interventions known. But implementation remains inconsistent. In many commercial settings, electrical stunning fails to reliably render fish unconscious. Poor placement of electrodes, inadequate voltage, or faulty machines may undermine the potential benefits. So we're basically just gonna give these fish shocks for no reason. It's not gonna knock them out. Percussive stunning, a physical blow to the head, has shown better consistency in lab settings, but it's difficult to scale. Fish vary in size. Yeah, if you have a huge net, kind of hard to bring a hammer to all of them, you know? Equipment must be precisely calibrated. Worker fatigue also reduces effectiveness. Any slip means the fish remains conscious while bleeding out.
This song slaps, chat.
Okay. That scared the hell out of me. Because I started hearing my voice, I'm like, where is that coming from? Thank you, Legolas, for the subscription. Why did my voice play, though, actually? That kind of freaked me out. Why? Whatever. It's fine. It's okay. Surf extension. Hey, this is not a music playing channel. We just set the music to random. If it comes on, it comes on. But I'll make that call. Let's see. So, new language for animal pain. What makes the welfare footprint framework powerful for its transparency? Actually, let's look into this. I have no clue what the welfare footprint framework is. Okay. So a group that research organization dedicated to quantifying animal welfare, basically to make sure, I guess, they're not undergoing any specific, just basically trying to make sure animals aren't abhorrently treated. Poultry stuff, Pain Atlas project, ambitious global initiative to systematically map and quantify pain across human and animal species. It's probably partly where this comes into play, using advanced AI technology to create the first comprehensive catalog of pain in living beings. Pretty good. Can I power the global map and quantification of animal suffering? Potentially. So let's see. Instead of assigning fixed label to pain, it works with the probabilities. If scientists believe there's a 40% chance the pain is disabling and a 40% chance is excruciating, the framework includes both. Okay, so I guess I wonder if this is exactly how the AI comes in play with the percentages. This makes the model flexible and more reflective of real-world uncertainty. Pain-like emotion varies between individuals. Some fish may suffer more than others, even under identical conditions. Which also, do they have emotional pain? All right, let's get a little summary of what's been going on so far, just so I can actually attempt to put that into practice and see how that goes. Let's see. Can a fish feel pleasure? Ooh, that's actually a very good null. Well, I don't know if it's a null hypothesis question, but it's a very good question that comes along with it. Asking for a friend. Is it your fish friend? I know the fish are in my chat and they are asking. Wait, why would the fish be asking? They should know. Alright, I'm gonna stop you right there. So basically, so far, ooh. Let's see, fish suffer from air. Did I spell that right? Tell me I spelled asphyxiation right. I know it's off the screen, don't worry about it. Dolphin and fish shouldn't be. Or at least, you know, I don't think it should be in here. Checking my spelling. ASPHYX. Oh, I added an S. Oops. And an I. Oh, no. XIATION. It was off screen. You didn't see it. You didn't see. I didn't misspell anything. You can't prove shit. Okay, maybe this... Here, let me... Thinking about how this will best work. Because I guess I can't really word wrap this, because it's just going to automatically push it off the screen. So I'm just going to have to manually do that myself. So there is no global scale for how to measure fish pain. I'm gonna have to find a different way to do this. Maybe I'll just pull up like straight up a Word doc or something. Because just using the text and OBS is not gonna work. Otherwise, I'm gonna have to keep constantly moving it around and everything. But it'll work for now. Alright, so let's see. So this is, I assume, just about rainbow trout. Okay. The welfare footprint framework provides a rigorous and transparent evidence-based approach to measuring animal welfare and enables informed decisions about where to allocate resources for greatest impact, noted Dr. Vladimir Alonso from Welfare Footprint Institute. This approach mirrors models used in public health or environmental science. Just like life years lost to disease, we can now talk about minutes of suffering saved. I guess I know that life years lost to disease was measured as far as terminal illness research. So let's see, implications for policies and people. Fish slaughter occupies only minutes in an animal's life, but these minutes can be extremely painful. Compared to long-term reforms on farms, slaughter improvements are easy to implement and affect billions of lives. The study's authors argue that investing in better stunning tools and training workers can provide enormous welfare gains. It does depend on how your farms run, though, and if they actually are being held accountable / actually try to train people that way. Let's see. For policymakers, this research offers a scientific foundation to reform outdated practices. Certification scheme can set minimum stunning effectiveness based on real pain data. Governments can use this to guide humane slaughter laws. For consumers, it gives a new way to think about what ends up on their plate. I also don't think this article is going to actually talk about the specific quantities of it, so when we get to the paper, I think we'll delve into that. Other fish suffer too. Though this study focuses on rainbow trout, the underlying stress pathways, oxygen deprivation, acidosis, metabolic failure are common across fish species. That means the welfare footprint framework can be adapted. Salmon, catfish, sea bass, tilapia, they all may suffer in similar ways during air exposure. However, each species will need specific data. Also, interestingly enough, yeah, this is only covering air exposure. And not necessarily like hook through mouth type pain. Some tolerate low oxygen better, others may react more strongly to ice. Future research must expand to include this diversity. A turning point for aquatic welfare. The world is just beginning to reckon with the sentience of fish. For decades, their pain was denied or ignored, but science no longer allows that. With trillions of fish slaughtered every year, even small improvements can have vast impact. The WFF doesn't just measure pain, it opens a language of empathy grounded in evidence. It lets regulators, producers, and consumers weigh the cost of change. And perhaps, most importantly, the framework acknowledges what fish have felt all along. Suffering that deserves to be seen and reduced. So, not that I am against helping fish suffer less. Sorry, I had to open a can. But at least with how this article is framing it, it sounds very... What's the right word? I almost want to say PETA-esque of being like, come on guys, we gotta help all the animals. Which again, nothing wrong with taking away an animal's pain and everything. But it almost reads that way. But anyways, that's kind of it for the article. If it makes it more expensive, let them suffer. True, that could also be a part of it. If it's more expensive for the farmers and stuff, then they may raise prices, or the markets could raise prices, and then it's going to make it a bit more, it's obviously going to reflect on the consumer. Thanks, economics. What if we just lobotomize every fish we come across, and then... Oh, it always comes back to capitalism. We can't escape it now. Yeah, I guess, let's see, bottom line. There is little regulations on fish pain currently. Alright, well, let's jump into the article and see what it provides. Because again, a big thing, like I said with that small example I had earlier of this article touching on long COVID and helping to alleviate symptoms. Well, I guess I didn't see an article, but the post that I saw it in painted it as, oh, we have the cure for long COVID. Or we know what causes it. That's not true. That's not what that article covered. It covered, hey, here's a thing that seems to make people with long COVID not suffer with it as much. Not necessarily taking everything away, but perhaps minimizing it very much. And even that was like, well, it minimizes like nasal congestion and like a few other things, not necessarily taking away things like the brain fog or the I was about to say like the breathing issues and everything that can come of it. So again, it's like a little like articles will definitely skew the story, but it's okay. You got me to read through all the BS for it. Alright, so let's see. This says, quantifying the welfare impact of air asphyxia and rainbow trout slaughter for policy and practice. Okay, so definitely, it seems like they just studied rainbow trout. And it does seem like they only covered air asphyxiation. Let me quickly go. It might be good to do this in the beginning. let's see if there's any conflicts of interest. Because if there are any conflicts of interest, you might want to keep that in mind while reading through the article. Acknowledgements, author information. Okay, yeah, so these were people that were with the Welfare Footprint Institute, Department of Biology at the University of Crete, Fish Ethology and Welfare Group, Center of Marine Sciences. Oh, they had like a good amount of people. Interesting. Okay, Welfare Footprint Institute is where most of their contributors came from. And then I guess they had other people help. So let's see, contributions, correspondence, let's see, declare no potential conflicts of interest. Okay, so we can at least consider this like there was no paid actors, basically, so far. But then again, you never know. Sometimes they don't even, not to get all conspiratorial, but they don't even always report this the way they're supposed to. But we'll go in mind saying like, okay, there was no like payment to be like, hey, we want you to put out this article to push this story, sort of. Like this study was paid by, for example, PETA or something. To which I would immediately then be like, oh, okay, then I don't trust this. Because boy, does PETA is not fully truthful with all their motivations and stuff. Anyways, so let's see. I guess we can read through the abstract. It's a long one though, damn. Also, this article came out just like almost 10 days ago. So this is recent. So, the effective improvement in animal welfare requires quantitative methods to compare diverse impacts across practices and policies on a common relatable scale. Basically, we really don't have any way to scale how an animal feels pain. And we should try to create one that is maybe a more global standard for animals. Which granted, like, who knows, like, maybe the way fish feel pain and, say, the way deers feel pain could be completely different. So I don't know if it necessarily would work, but we'll see. The Welfare Footprint Framework fulfills this need by providing a standardized welfare impact measure, cumulative time, and effective states of varying intensities. So I guess basically, like, you poke them, they feel X amount of pain, they die by air asphyxiation, they feel this much pain. To this end, WFF estimates rely on documented syntheses of existing research, including behavioral, neurophysiological, and pharmacological indicators. We applied this framework to quantify the welfare impact of air asphyxia during fish slaughter, using rainbow trout as a case study. Based on a review of research on stress responses during asphyxiation, we estimate 1.9 to 21.7 minutes of moderate to intense pain per trout, or 24 minutes per kilogram. Cost-effectiveness modeling shows that electrical stunning could avert 60 to 1,200 minutes of moderate to extreme pain per US dollar of capital expenditure, but commercial performance remains variable. So basically, anything could change. Per USD, it could basically, wide range by the way, avert 1 hour to, hold on, let me do some math. Very, very wide range they're claiming here. Okay, yeah. Can be anywhere from 1 hour to 20 hours worth of pain aversion. So we'll see where that statistic comes from. Percussive stunning demonstrates reliable effectiveness, but still faces implementation challenges. Again, you're not gonna have a guy with a table in front of him and then just with a hammer and bopping each of them on the head. Just going one by one, like smacking them all. These findings provide transparent, evidence-grounded, and comparable metrics to guide cost-benefit decisions and inform slaughter regulations and practices in trout, and potentially other species. With over 1 trillion fish slaughtered annually, they also demonstrate the potential scale of welfare improvements achievable with effective stunning methods. So it sounds like more or less it's like this is less about do fish feel pain, and it's more how can we decrease the pain they feel. Or someone pop you on the head with a hammer. Hey, sometimes all you gotta do is find the right people and ask, you know? Alright, so let's see. Societal concern about the impacts of production practices on animal welfare is raising. Actually, let me type that in. So this study looks how to minimize the pain fish feel. Oh. Alright. You wish a giant hook would come to the sky, rip you to the atmosphere, followed by some cosmic titan beating you over the head with a club. Well, that's elaborate, but who am I to tell you otherwise? Live your dreams. We can all have our fantasies. So let's see. Societal concern about the impacts of production practices on animal welfare is rising, as evidenced by consumer-driven movements, labeling efforts, accreditation schemes, policies, and legislation that prioritize animal welfare. The need to consider animal welfare within sustainability assessments is also increasingly recognized, as environmental gains cannot be justified if they occur at the expense of animal welfare. While environmental and human welfare considerations such as poverty and health have long benefited from well-established quantitative frameworks for policy analysis and decision-making, environmental footprints, disability adjusted life years. Another quick note. It's also good to look through some of these articles, and if there's ever a sentence that you were like, you know, even if it's just a random like sentence they have in there or a claim they make, you can always be like, hey, is there a source next to that sentence that they got that from? And if they don't even have it, you can basically take that as, okay, this paper itself is making that claim. If it seems like it's out of nowhere, you can be like, okay, this article is making this claim based on either their own study or basically nothing. And even then, like, sometimes you look, if you think something's a little dubious, a little claim's dubious, you can go look at the source and then be like, oh, like this source could be the primary source where this is claimed. I guess basically I want to demonstrate it is actually so difficult to look into scientific research and find what's real from, you know, basically reality and just like paid stuff, like things paid to make it look like something is like a certain conclusion. And I'm not expecting people to do that, because obviously that's insane that you have to do that with literally everything. But just, you know, like sometimes nowadays you kind of gotta do a quick little like, oh, let me look at this, and then it's like, okay, they have a source or an article or whatever making that claim. It's good to double check sources. Anyways, animal welfare assessment has historically lacked comparable tools. Yep, so still don't really have any specific standard to measure pain. Still, the effective allocation of limited resources to improve animal welfare depends on the ability to compare the impact of different policies and practices with a common metric, so prioritization of the most cost-effective improvements may be possible. Okay, so they're taking into account that there could be some cheap ways to make it to where fish aren't feeling pain. For example, producers comparing potential practice improvements, advocates selecting campaign priorities, and policymakers designing regulations all require quantitative measures to determine which interventions yield the greatest welfare benefits relative to their costs. Scientifically substantiated, so they aren't going to take like the most expensive path, basically. If you say like, yes, we can do this, but it costs us trillions of dollars, then they're going to be like, hell no, we're not implementing that. Scientifically substantiated quantification of animal welfare using a comparable metric is also a prerequisite to properly value financial incentives connected to welfare standards and objectively assess trade-offs between animal welfare, economic, and environmental policies. A recent approach, the Welfare Footprint Framework, WFF, one of the sources just, I guess, basically talking about the WFF, addresses this need by providing a scientifically rigorous methodology for quantifying diverse animal welfare impacts through a standardized measure. The cumulative time animals spend in affective states of varying intensities. So that's basically what they're proposing. It's like, hey, this is the metric we want to go by, is the amount of time that animals spend in pain. Similar to life cycle analysis, the WFF begins by defining the scope of analysis, followed by an inventory of relevant circumstances, handling procedures, housing, density, air, water quality, and their biological outcomes, injuries, diseases, deprivations over a time frame of interest. The impact of these biological outcomes on welfare is evaluated by estimating the intensity and duration of each resulting effective experience. Using extensive evidence from multiple research lines. By quantifying the total time animals spend negative... Oh, you know what? I know what's going on. Hold on. YouTube loves to do this thing where it's like, hey, are you actually still listening to music? It's like, YouTube, damn you for making me have to click on you. Damn you for making me have to do that. Let's see. By quantifying the total time animals spend in negative and positive affective states of different intensities, the WFF provides a comparable and relatable metric that is applicable across scenarios and species. Which, again, they provide a lot of sources here, so I think they are really trying to get the point across. Like, hey, listen, this is something that's backed by a bunch of different research. I know I do the same thing when I'm basically like, I don't want people questioning this. I'm going to give them like 3 to 5 sources to be like, look, do not question me on this, okay? In this study, we apply the WFF to quantify a pervasive source of vertebrate suffering, the slaughter of fish. Welfare of fish at the time of killing is currently at the center of policy discussions in multiple jurisdictions, with an estimated 1.1 to 2.2 trillion wild fin fishes and 78 to 171 billion farmed finfish killed annually. The scale of potential welfare improvements is substantial. However, decision-making is hampered by a lack of standardized metrics for evaluating the welfare impacts of different stunning and slaughter methods on a common scale. This study addresses this gap by quantifying the welfare impact of asphyxia in air, a prevalent slaughter method in fisheries and aquaculture at a global scale. So basically, I guess a lot of fisheries just bring them out of the water and let them die naturally that way. And so it's a relative good metric to look at. We use the rainbow trout as a case study, given its global importance in aquaculture and the existing research base on its neurophysiology and welfare. Our findings provide the first quantitative estimates of pain during fish slaughter, demonstrating the potential scale of welfare improvements achievable through effective stunning methods. Let's see, welfare impact assessment, the welfare footprint framework. Animal welfare footprints quantify the impacts of practices, policies, or conditions on animal welfare. The WFF expresses these impacts through a fundamental metric that connects directly to animal experience, time spent in different affective states. By measuring welfare in units of time, such as hours of pain or pleasure at varying intensities, so there you go, they can look at pleasure as well for the fish. The framework provides a concrete, relatable scale for comparing welfare impacts across scenarios. Here, the terms pain and pleasure are used as shorthand for negative and positive effect, respectively. The WFF, so basically, anytime they use pain, it's any kind of negative effect, pleasure, any kind of positive effect. The WFF uses a structured assessment approach. First, it establishes analytical boundaries such as the geographies, production systems, breeds, life stages, and circumstances of interest. Which, yeah, I guess I didn't even think that do fish feel pain at different life stages. Here, the analytical boundaries are limited to analyzing the impact of air exposure for the slaughter of rainbow trout. The assessment spans from the moment of immersion to loss of consciousness. Exposure to ice or ice slurry, handling or pre-slaughter practices to which fish are exposed are beyond the scope of this study, with these other practices varying substantially depending on the species and commercial conditions. So this is a big caveat sentence right here. Are there fish that can be circumcised? I don't know enough about fish genitalia to tell you that. I don't know if anything has... This isn't necessarily a fish, but I know barnacles have the largest penis to body length ratio. But I can't tell you if someone has actually tried to circumcise a barnacle. Unsure of that. But okay, this is basically saying this study literally only covers the, like, death by air asphyxiation. And that's it. If there are fish with foreskin, then potentially. But are these questions you want to ask yourself? This is basically saying current methods of putting fish on ice or ice slurry to slowly kill them and slowly make them not feel as much pain. And how they are handled before they are killed is not covered in this. So that it's important for studies to do that so that you can be like, okay, this doesn't cover that, so I know specifically what kind of group this would fall under or what it would affect. And it's even saying like, hey, this, like, other species could be different, other conditions can change. So we're just going to focus on rainbow trout and air asphyxiation. This focus scope enables establishing a baseline understanding of a welfare impact, asphyxia in air, that is still widespread in both fisheries and aquaculture, while acknowledging that total welfare impact during slaughter will be greater when considering these additional circumstances. So basically, future research to do stuff like this. The second step involves identifying the biological outcomes of the circumstances of interest. For air exposure during slaughter, the primary biological outcome is asphyxiation. Next, the welfare impact of the affective experiences arising from each outcome. Here, the pain and distress associated with asphyxia is assessed by estimating both how long the experience lasts and how intense it is. So basically, is the fish being like... or is it going, ah, help me, ah, when it's dying? The subjective assessment of indirect evidence is inherent to all animal welfare assessments. Behavioral indicators, vocalizations, posture, activity, neurophysiological measures, and responses to pain-relieving drugs are widely used to infer the presence and severity of affective states, often through expert judgment. For example, the European Food Safety Authority's risk assessment model relies on literature reviews and expert elicitation to assign intensity scores to welfare consequences based on their perceived pain and distress. So difficult because they're basically saying, okay, we have, again, just quantification is the hardest thing, but you can't really have data without some sort of quantification most of the time. Because it's like, in this, they're basically saying like, yeah, that fish looks like it's having a 6 out of 10 on the suffering scale, but there's not exactly a way they can effectively cover it. In the welfare quality protocol, experts estimate the severity of different issues on a 0 to 100 scale, then aggregate into composite scores. In the 5 domains model, I guess that's something, experts grade welfare compromises on a scale A to E based on their evaluation of indirect indicators. So yeah, we got a 0 to 100 scale and an A to E scale. In the WFF, the subjectivity inherent to this process is constrained in several ways through a process that ensures explicit and documented disclosure of evidence to judgment pathways. First, it breaks each experience into meaningful time segments, recognizing that intensity typically changes over time, e.g. sharp pain might dull during healing. Segmenting time allows for more precise matching of existing evidence to each phase of the experience. Second, the framework guides assessment by defining specific criteria for each intensity category. Okay, so we got first table shows that. For example, more intense pain sensation should be more disruptive, engaging more intention, and requiring stronger doses of pain-relieving drugs. More pain probably creates bigger, effect. Each piece of evidence is then evaluated for its consistency with these criteria. For example, supplementary information basically thinks that they're like, we don't think this is super important to put, like, on the main body of the paper, but, like, if you're super interested in that data, supplementary information, you can go check it out. For example, evidence that a pain experience requires high doses of strong analgesics for relief would be rated as consistent only with higher intensity categories. This structure and explicit evaluation process ensures transparency and constrains subjectivity by rooting estimates in documented evidence rather than relying solely on expert opinion. Basically a way to be like, yeah, so that way we don't have to guess. Third, the WFF acknowledges uncertainty and natural variation in how animals experience conditions. Some animals may feel pain more intensely or may take longer to recover. Thus, rather than assigning a single fixed intensity or severity category to a welfare challenge, as in other welfare assessment models, e.g. 0 to 10, A to E, 0 to 100, 0 to 1. Interesting. So there's a model that basically says 0 to 1 on feeling pain. Oh, wait, not 22. Novel metric of animal welfare that combines the impacts of impaired welfare and abbreviated lifespan. Let me take a look at this real quick. So I want to take a look-see. True. If we get more money, we could just learn fish language to ask them about their pain. I'm just going to take a quick glance through this, but it basically sounds like they, or at least how our paper's putting it, it's like 0, not pain, 1, they are feeling pain. Let's see. Separately to allow comparison of fun. Okay, or maybe 0 to 1 for like each of these things. I know it's a little covered, but anemia, musculoskeletal problems, diarrhea, cancer. Interesting. But hey, I'm sure if I were to look up right now fish language, I'm sure we could find an article about it and talking about it. Whoop. Oh wait, okay. Where was I? For instance, if evidence is insufficient to differentiate between two intense categories, e.g. hurting and disabling, a 50% possibility is assigned to each. Likewise, uncertainty ranges are used for duration estimates, finally through a notation system known as pain track or pleasure track for positive experiences. Estimates are made explicit to allow for review, criticism, sensitivity, analysis, and update as new evidence emerges. So basically, as science continues to learn more, there can be updates to the system that they make it. Let me look at the table. This is a table of summary definition and expected observations in 4 categories: annoying, hurtful, disabling, excruciating, of intensity of negative affective experience. The term pain is used as shorthand for any negative affective experience. Okay, so this is, I guess, how they're looking at pain. Or how, I guess this is a table of their definitions of pain. So I have annoying pain, which is perceived only as a discomfort. Hurtful pain, which is pain intensity that clouds focus but allows basic tasks. Disabling pain, pain that takes priority over most bids for behavioral execution. and excruciating pain. Extreme level of pain felt unbearable, even if very brief. So let's see. Disruption of ability to conduct routine activities. No, okay. So this is, yeah, again, this is just like heavy defining of their definition of pain and what kind of pain. And basically saying like, does this level of pain affect their attention and surroundings? Annoying pain, not affected. Hurtful pain, reduced to some degree. Disabling pain, their attention surroundings is substantially reduced. And excruciating pain, their attention is exclusive to the pain. Let's see, how long can pain be tolerated? Continuously. Major impairment of life quality can be willingly tolerated only for seconds to minutes. Are pain relieving drugs effective? No effect expected. Typical doses in drugs can eliminate pain. Only higher doses. Powerful analgesics may only reduce pain. So yeah, basically, yeah, just they're defining of pain for everything. They do keep mentioning pleasure, but it doesn't sound like they're really going to cover it. So I don't know what we'll see there. Cumulative pain or pleasure are calculated by multiplying for each cell in the pain or pleasure track table. Okay, maybe they are going to. Let's pleasure some fish. Probabilities by its segments, duration, and summing the results across segments within each intensity. Oh, here we go. Figure 1. Okay. So, what we got here? We got a pain track with hypotheses on how pain, negative effect, intensity changes over time when trout are removed from water until loss of consciousness. Vertical axis shows pain intensities defined in Table 1, where pain is short. Okay. For each segment, 1 to 4, estimated probability that the fish experiences each intensity can be traced back to the evidence reviewed. So let's see. This is basically their percentage of alarm immediately after air exposure. If it's annoying, then I guess they don't feel any alarm. If it's hurtful pain, that is a garage door outside, by the way. If you can hear that shrieking squeal. Although I forget, is this percentage of the fish, or is this just percentage chance that they do react to it? Estimated probability that the fish experiences each intensity can be traced back to the evidence reviewed. Okay. So I guess in Table 2, which is the summary of evidence on intensity of unpleasantness of air exposure. No pain, annoying, hurtful, disabling, excruciating. Okay, so this is all their evidence reviewed. So air exposure for as briefly as 5 seconds triggers the expression of neuromolecular states associated with negative emotions in fish. What is the R? Reject. Consistent, or plus equals observation consistent with intensity. Minus is observation inconsistent with intensity. R is reject, observation rejects the intensity. Or a question mark, which is unclear. So basically, this is saying that it reject. Okay, let me put it this way. Basically, for this air exposure, 5 seconds of air exposure, they don't feel no pain. They will feel pain. Is basically what it's saying. Like, it's either going to be excruciating or it's going to be disabling pain that they feel after 5 seconds of air exposure. And I think the Minds was saying that it was inconsistent. So basically, like consistently, they will feel pain for this. Maybe some fish felt annoyance after conditioned place aversion occurs for air exposure associations. So yeah, basically just a whole table of figuring out like how they got their percentages for everything. So let's see. Metabolic exhaustion. So this is all like pretty equal. I guess that's maybe partly the case study reasoning, or at least like using such small percentages. Because these all look like just like this is a third exactly, you know? So I'm pretty sure they probably just took like one thing and then divided it. So let's see, what's this next part? Cumulative pain table showing time and pain at each intensity. Since segments 1 to 3 have identical probabilities, they're analyzed as one time period for cumulative pain calculation. So if any of this stuff happens to it, you can calculate like there's going to be this much amount of pain. Okay, let's see, where are we? Since time estimates can be meaningfully combined, it is possible to estimate cumulative time and pain or pleasure in any period due to all experiences endured. For populations, impacts are estimated by considering the prevalence of each experience. For instance, if a disease causing 10 days of pain affects 30% of animals, this represents 3 days of pain for the average population member. Okay, yeah, so I see. So it's basically saying if this many minutes of pain affects, like in the other table, say 40%. Oh wait, not that one. Figure 1. Yeah. So if it affects 40% of the animals, then that's that much amount of pain per animal, per single animal. Additionally, time spent in different intensities can be also meaningfully combined into a single scale when needed. For instance, minutes or hours in hurtful, disabling, and excruciating pain can be added together to report total time and moderate to intense pain, while maintaining the granular, disaggregated data for detailed analysis. Woof. Though individual level and population average estimates are crucial for understanding welfare, impacts can also be expressed per kilogram of production. This dual reporting serves several purposes. First, it allows meaningful comparison between productive systems with different efficiency. For example, extensive systems may have better individual welfare, but require more animals to produce the same output, meaning more total suffering could occur despite better conditions for each animal. Second, it enables cost-effectiveness analysis such as those needed for policy decisions that must balance welfare improvements with economic considerations of cost per production output. Basically, we could, it's basically saying we could put them on a little pillow and put them to sleep and just give them a little injection or something and they would go peacefully. But obviously, no industry is going to be like, yes, let's do that because we care about the fish so much. Third, production standardized metrics also empower consumers who typically purchase animal products by weight to understand and compare the welfare impact of their purchases. So I think, basically talking about like you obviously buy, we measure fish by weight and price them as such, so people are going to take that into account. They complement rather than replace individual welfare assessment. While efficiency matters for comparing systems, the moral significance of individualized suffering remains unchanged regardless of their productive output. Okay, so last bit, then we get into results, then discussion. I'd say we're probably like a third of the way through this article at least. So let's see. Temporal evolution of asphyxia and induced stress. Hold on, drink break. And if there's any rambling that I'm going on that you guys don't understand, ask me to re-explain. Because I can do that easily. So let's see. Following analysis presumes the sentience of fish and their capacity for pain and distress as supported by a robust body of evidence. We review existing evidence on temporal evolution of the stress responses triggered upon immersion, categorized into the following time segments. 1. Initial air exposure. pH imbalance and hypercapnia. I have to actually look this up. I don't remember what hypercapnia is. Too much carbon dioxide in blood. Metabolic exhaustion and depressed neuronal activity. Basically, If you're not getting oxygen to your brain is dying. And that was the evidence that we looked at in Table 2. So let's see. Segment 1, initial air exposure. Air exposure is one of the greatest stressors for fishes. Used as a reliable stress-inducing procedure in research, as little as 60 seconds of air exposure has been shown to elicit a physiological stress response consistently greater than that triggered by longer-lasting stressors. I wonder what stressors they're talking about. Let's see if it says in the title. Exposure to low water and air exposure. Oh, let's see. So basically just complete air exposure, I think, rather than like low water level. Notably, air exposure is the only stressor capable of causing hydromineral disturbance within such a short time frame. Other stressors, hypoxia, crowding, handling, require longer exposure to elicit comparable responses. So basically, you take fish out of water, it's gonna hurt it way fucking more than just having it basically all of them shoved together in one little tank. I don't know the numbers so far of how many fish they looked into this with, but they really do just be saying like, yeah, these fish feel crazy fucking pain, dude, but we gotta test it to learn about it, I guess. But just taking them out here, or just being like, what if we put them in a little tank with like 500 other fish, but no water? Let's see how they feel about that. When fishes are removed from water, their gill filaments adhere and gill lamellae collapse, preventing oxygen uptake and CO2 excretion. The acute stress from oxygen deprivation triggers out of hormonal responses that suppress non-essential processes. Basically, they start losing oxygen, their body's gonna send off a bunch of hormonal responses to be like, hey, what's going on? You're dying. Under normal conditions, there would be an increase in energy substrates and oxygen to the muscles and cardiorespiratory system to regain homeostasis. Love homeostasis, by the way. Big fan. But this mechanism is compromised out of water, and energy reserves are quickly depleted. It's basically, obviously, they can't do anything to get oxygen out of the water. So, very quickly, they just run out of energy. Intense physical activity prior to immersion exacerbates the physiological effects of asphyxia. So basically, if they did a bunch of exercises swimming beforehand, then they're going to run out of oxygen quicker. Quickly exceeding stress coping ability. Indeed, there is a substantial suppression of coping mechanisms in the brains of trout exposed to asphyxiation with impaired expression of stress-related proteins. So they probably could measure that out as well. While physiological stress can be an adaptive response, air exposure is highly aversive and detrimental to most fish species. So basically it's saying, yes, physiological stress, like, we do have responses to that and adaptations to it, but air exposure, very bad for fish. Air exposure is very not good for fish. Just in case you weren't aware. As soon as individuals are out of the water, intensive aversive reactions and movements are observed. Even a few seconds of air exposure has been associated with the expression of neuromolecular states associated with negative emotions. Few seconds of air exposure, they will send out little brain molecules that will be like, I don't like this. I really don't like this. Let me just add that real quick. Hold on. Fish don't like being out of water. It hurt. Just in case anyone need a reminder on that. Let's see. So including higher expression of markers of neural activity in brain regions homologous to those involved in version processing in mammals. But, I will say, I do know we're clowning on this a little bit, being like, well, yeah, of course of course the fish are like, hey, we hate this and it sucks. But it is good to reiterate and basically explain things. Even though this is like a relatively higher level thinking like paper, you do have to explain everything like whoever is reading it is a 2-year-old, Like it might have the jargon of an adult, but it has to have the processing of like a child, so that people can follow along and can be like, step by step. That's just how it is. I think those are the best papers, honestly, too, because if you fill your paper with jargon, but no one can really follow along what the hell you're saying, it's useless. If you have some jargon and if you but you can, like, some Joe Schmo can read it and be like, oh, I kind of get it, then that's good. That's good that they can do that. Average American adult has a 5th grade reading level. Yeah, I haven't looked too into it, and maybe I will, but I've been seeing American reading levels have been, I guess in children and adults, has been going down. COVID, let's be honest, had some real fucking detrimental effects on our society. Not that it was going super amazing in the first place, but man, those years of online schooling really fucked some people up. All right, hold on. I gotta let my cat out. He has requested to leave. Hold on, let's see if I... Would you like to talk? Huh? Do you want to say something? You got anything to say about fish being basically killed in the air? He's got nothing. Your poor little brain can't comprehend it, can it? Out you go. So anyways, I'm glad this paper does kind of semi-treat us like children. Because even that too, even if you want your paper to be understandable, you gotta also remember that people, even if they do scientific research, have different fields of study. So someone that does one field of study might not understand this other field of study. So even if they could comprehend it, or at least like read through it and understand certain things, they might not understand the basics of, like, hey, what the hell's a fish? Actually, I guess they haven't gone to that level. It's a weird balance. It's very much a balance of, okay, is this information important enough for me to put in, or can I hope that anyone that reads this know what a fish is, So there is actually that weird balance you have to take into account when creating a paper. You want to explain the basics, but how much foundational basics do you need to explain to get this point across, So that's a fun little thing that people gotta go through. All right, anyways, let's see, where did I even stop? Okay, anyways, Airbad. Hey, you're a fish and confirm based on my summary. This is all very educational. Thank you. I'm glad we're getting a fish opinion here. I was really worried we wouldn't have the diversity input that we needed. I didn't want to speak for the fish. Alright, let's see. Evolutionarily, it is adaptive for the unpleasantness of air exposure to be very intense, because even a few minutes of exposure poses direct and severe threats to survival. So basically, yes, fish evolved to adapt to being out of water bad, stay in water. Otherwise, they're just gonna flop onto the shore and die, even though they kind of do that anyways. This intense unpleasantness acts as a powerful aversive signal, driving immediate escape behaviors to return to water. Such rapid responses are crucial for minimizing the risk of suffocation and enhancing survival chances in natural environments where accidental stranding or low water levels may occur. Okay, so hypercapnia and pH imbalance. When metabolic CO2 in the blood increases, that's hypercapnia, additional disturbances are triggered. CO2 combines with water to form carbonic acid, which, if I remember correctly, I'm pretty sure that's what we use for soda. Carbonated beverages, yeah, carbonic acid. I fucking got with this either last year or earlier this year, where I was I was doing a cave tour, and someone asked, or basically said, like, oh yeah, the water's filled with carbonic acid, and they're like, does that sound like something that, like, you would drink, or, you know, that would be, like, dangerous to people? Fucking leading the question. And I, along with a couple other people, like, yeah, sounds bad, I wouldn't do that. And it was like, well, you probably do it a lot because it's in soda. And I'm like, you motherfucker. So yeah, carbonic get your friends with that one. Ask them if they would drink carbonic acid, and if they say no, be like, ha, you fucking idiot. That's what we use in soda. Anyways, carbonic acid dissociates into bicarbonate and protons. I did get debated by the tour guide. Is a shrimp a fish? That's a good question, because honestly, even... Let's see what Google has to say. Is shrimp a fish? Shrimp are not fish, according to the AI. These are aquatic invertebrates and technically not fish. Ooh, shrimp is a fucking liar. Shellfish is used as an umbrella term for a wide variety of shelled organisms that originate in the water. Someone is fucking lying. Since the capacity of hemoglobin to buffer hydrogen is limited, blood pH is reduced. Oh, I'm sorry. Your best friend is a fish? Why don't you get out of here, you little speciesist? That doesn't make it okay. You are not fishkin, okay? You can't just say that. Let's see. Acidosis is further enhanced by the increased concentration of blood lactate, an acid waste product of the anaerobic metabolism. Before anyone says anything, something, yes, lactate blood. Maintaining proper acid-base balance and arterial CO2 is critical for survival, so subtle changes in pH and carbon dioxide trigger prompt responses to these threats. The excitability of neurons is especially sensitive to changes in pH, increasing respiratory drive to remove excess CO2 and protect against acidosis. However, this compensatory adjustment is impaired in the air as gas exchange is inhibited. In fish, CO2 is readily detected to other noxious chemicals have been identified. Supporting the notion that hypercapnia stimulates the nociceptive system and is painful. Symbolic of CO2 aversiveness is its use as a non-physical barrier for fish and mechanism of self-transfer between tanks. Yeah, lactated blood is very healthy, guys. Definitely don't go to your doctor if you are bleeding from your nipples. It's perfectly natural. I feel like I can't... I feel like in a science stream, I shouldn't make jokes about things like that. Because I don't want people to take anything like that seriously. If you are bleeding from your nipples, go to the doctor. Go to the doctor. This is not a joke. I think I need to... I'll caveat my jokes now to make sure that someone doesn't come in here and be like, oh, like, he's a scientist. He's talking about a science paper. So, like, if anyone can't read sarcasm, then they're like, oh, is that natural? Like, that's perfectly fine. And then just be like, yeah, no, that is not fine at all, actually. Very much don't let that happen to you. Thank you, appreciate that. So I'll caveat jokes from now on. This is a joke. Cut off your nipples and serve them in the soup. This was a joke. That was a joke. Don't do that. Do not do that. We joke here, but also there's real science. Trust me. But also, that was a joke. Don't do those things. So let's see. Yeah. Obviously, we adapted to not take in too much CO2. However, this compensatory adjustment is impaired in the air as gas exchange is inhibited. In fish, CO2 is readily detected even at very low concentrations. So if they can't get oxygen, they can't really exchange CO2 out. CO2-sensitive receptors that respond to other noxious chemicals have been identified, supporting the notion that hypercapnia stimulates the nociceptive system and is painful. This is your nervous system. Basically, let's see, I forget. Okay, yeah, that's just your system that tells you what hurts. Symbolic of CO2 aversiveness is its use as a non-physical barrier for fish and mechanism of self-transfer between tanks. Importantly, research has shown that CO2-induced behavioral effects on larval fish can be reduced using analgesics. Exposure to higher levels of CO2... Wait. On larval fish. So basically, you can reduce their responses to having a little bit of excessive CO2 if you give them some drugs. Exposure to higher levels of CO2 also trigger a feeling of severe breathlessness, an increasingly distressing urge to breathe. Accordingly, vigorous behavioral reactions, escape attempts, and gasping are observed soon following exposure to higher CO2 concentrations. Evidence is also robust that acid-base imbalances lead to anxiety and panic. In fish, hypercapnia triggers the release of catecholamines proportionally to the severity of the acidosis. And strong catecholamine stimuli are known to induce panic attacks in humans. So basically, if you have a lot of, catecholamines going on into you, then you might get a panic attack as a result. Give me 1 second. I need to... Actually, can I fix this? Hold on. I want to see if I can log into this. Smoking the Mary J. Whatever. You know, it's fine. It's fine. I just think I wasn't logged into the chat, so I couldn't interact with it, but I'll live. Smoke them if you got them. Alright. Moreover, CO2-induced aquatic acidification reduces the action potential of GABA receptors, an inhibitory neurotransmitter that controls nerve cell hyperactivity due to anxiety, stress, and fear. The GABA-A receptor dysfunction has been directly linked to increased anxiety-like behaviors in rockfish, with behavioral changes reversed upon return to normal CO2 conditions, indicating the causative role of CO2 in inducing anxiety through GABA-A receptor alterations. CO2 is among the most well-studied substances that induce anxiety and panic-like responses across vertebrates. In mammals, hypercapnic environments with only 7% CO2 trigger fear, anxiety, and panic, with brain regions and neurotransmitters involved in negative emotional responses activated by hypercapnia and acidosis. So for example, if you are in an environment that is has a very high CO2 level. And, you know, just sort of that feeling of like, hey, something feels off, something feels weird or scary. You know, that could be what's causing it. So if you just walk into a place and you immediately feel like something is wrong or you're like afraid just like all of a sudden, see if there's a carbon dioxide or a carbon monoxide detector around to make sure you're not you're inhaling too much CO2. While direct evidence of anxiolytic relief of CO2-induced fear, specifically in fish, is limited, demonstrated role of GABA-A receptor dysfunction, both CO2-induced behavioral alterations and anxiety strongly suggest shared mechanisms across vertebrates. Oh no. Oh well, it's fine. Yeah, CO2 is one of the primary things that plants need to grow. Which crazy mutual beneficial relation that we have with them, huh? I feel anxious all the time. To be fair, the potential could be there. I mean, you would probably see other effects if you're constantly being given too much CO2. Yes. More green. Well, actually, hold on. I want to divert real quick. Let me see if I can find it. Because you just reminded me of something. I did watch a video series where a guy did try to see how much essentially plant like how much plant air exchange we would need to be able to just like breathe. Let me see if I can find it. Oh, God, how do I even search this? Joel Creates. That's the channel. Let me see if I can find his latest video on it. Because I listened to these and I was like, this is an amazing like little case study. Okay, hold on. You might hear. Oh, no. Let's copy that. This was, I think, like a super cool thing, and we're not watching the whole thing. I just want to show this.
Deep inside my base.
Okay, so basically, this is like the third or fourth video that this guy made for this, but
There's a.
he created a little room in his basement. Created basically, I don't want to say it's not a vacuum, but like just an air chamber where, you know, air cannot get in and out of the room, and he can only, he only has these huge algae tanks to breathe, because several. Actually, you know what? Let me go to the beginning. Let me go to the first one. You know, let me go to the first one. Did he explore this earlier, or is this it? Okay, maybe this one.
Picture this.
Here, let me just get to it. So, basically, he saw this article that said, oh, snake plant is most effective plant at producing oxygen. So, he went through this whole thing where he tried to create a room with just snake plants to try to breathe in the air. And, you know, it wasn't working. And so he found out that algae is actually like better for this. And he just like basically measured his CO2 level the entire time, his oxygen levels, and, you know, basically see how long he could stay in there. It's really, really interesting. Here, I'm going to go ahead and link it just in the chat, and I'll put it on the YouTube VOD as well. But I think Oh, wait. Fuck. That's literally what was one of the issues, was I couldn't access the chat. Alright, hold on. Pause. But it was a super, super interesting study that he did. Super interesting study. Don't listen to me. Alright. Yeah, here's that video. Super cool. Oh wait, did I send it with... Okay. I hate when people send things with a random ass timestamp. And so basically he revisited it. He had to have... These are full of algae. And he had to basically... you know, apparently algae is also extremely hard to, like, maintain and to grow. So he had to take all these factors into account to do. Yeah, here's his little spaceship. Here's, like, his face mask. So he's only breathing in air from the algae. He would, like, basically eat. And then, you know, if he needed to breathe, he would breathe in through the little tube. I think this is... Let's see. Yeah, he's showing, like, the air levels and the CO2 levels. So as the CO2 is rising throughout his stuff.
Since now, I would be able to run with all
Also,
the
he
tank
realized
lights
he had
on
to clean
and the
the
extra
tanks.
pump running that I had added somewhere in the testing chaos of trying to fix the algae. I feel weird mentioning the pump in such an offhand manner, and I would have told...
Fine, it didn't look bad.
Yeah, here's his
Even if there
timer,
was
so
a
he's
tiny
been there
leak,
for, like, half an
it
hour.
wouldn't make this much of a difference. This is insane. This is insane. Thank you for being with me.
And speaking of being with...
And so it was, like, again, super cool. I loved watching it, learning about it. Did think about doing a little stream somewhat similar of, like, talking about, but I was like, eh. But anyways, I went off the rails hard. It's just really cool, and, like, you know, it's relatively inconsistent, but it's also hard to do in such a measurable way because there are so many factors he had to take into account, like with cleaning the algae tanks and everything. Wow, I just fully broke this dock, huh? Let me see if I can fix this. Because now it's pissing me off. Or maybe I can't. Maybe it's just dead. Oh well. I'll worry about it after stream. So, anyways. Moving on. Metabolic exhaustion. The vigor, frequency, and duration of muscular activity is progressively reduced sometime after removal from water. Several authors suggest that the time it takes for fish to be completely still is most likely modulated by metabolic exhaustion rather than insensibility. The time until metabolic exhaustion can vary greatly between and within species, as metabolic rate is modulated by several factors, including body mass, energy reserves, anaerobic scope, and temperature. Oh wait, what am I thinking? I don't have to just put it... Hold on, sorry, I was just like, I don't have to wait for the VOD to be up. I can just throw that bitch in there. Let me do that real quick. Sorry, YouTube chat, I just kind of forget to watch over you sometimes, but I got you, don't worry. Okay. And I'll put it in the bond as well after. It worked. Oh, sweet. That's good. I've been trying to figure out YouTube and Twitch chat, and it looks like it works, so that's very good. Anyways, let's open this back up. I think this is decent and still kind of describes things we've gone over so far, unless people want some more specific details. So, several authors suggest that the time it takes for fish to be completely still is most likely modulated by metabolic exhaustion rather than sensibility. Which also they could technically move through, I wonder just like after death brain functions. The time until metabolic exhaustion can vary greatly between and within species, as metabolic rate is modulated by several factors, including body mass, energy reserves, anaerobic scope, and temperature. So basically, this study can't cover it super well if they're just going with rainbow trout. When oxygen is lacking, a switch to anaerobic metabolism occurs, which is less efficient at generating ATP and leads to the rapid depletion of glycogen and accumulation of lactate, further reducing pH. As pH becomes more acidic, acid-sensing ion channels and neurons are activated. Lost my place. Oh my god. Oh, okay. Here I am. This can lead to depolarization of neurons, which might manifest as heightened sensitivity to sensory stimuli, including pain. Additionally, metabolic acidosis may also trigger specific pain receptors. As lactate continues to accumulate, it inhibits key enzymes involved in energy production, further limiting the ability to maintain high-intensity efforts. Besides exhaustion, individuals are still exposed to hypercapnia and acidosis. They may also experience ischemic pain due to insufficient oxygen supply to tissues, and pain from high levels of lactate. Ischemia can also trigger the release of inflammatory mediators, increasing pain. Second 4, depressed neuronal activity. In addition to acidifying the blood, CO2 also crosses the brain-blood barrier, causing cerebrospinal fluid acidification. This ultimately results in unconsciousness, namely loss of the ability for subjective experiences, inferred through visual and neurophysiological indicators. Loss of equilibrium. Basically, if you got too much CO2 in you, big bad, absence of the vestibulo-ocular reflex and visually evoked responses to light recorded by electroencephalogram. Acidification can increase the concentration of glutamine and gamma-aminobutyric acid, a major inhibitory neurotransmitter, and decrease that of glutamate, an excitatory neurotransmitter. If there's too much CO2 in your body, your brain's gonna start dying. Okay, I was like, am I hearing double sound right now? Wait, actually, am I? No, I think it's fine. It's just the song. This process is likely gradual, with an increasingly greater level of neuronal necrosis until loss of consciousness. Once consciousness is lost, movements can still occur, such as irregular muscle contractions. Yeah, so I was thinking. Trembling of lower jaw and fins. These movements are likely due to local muscular activity rather than consciousness responses. Alright, so we're finally at the results. Based on the evidence reviewed in the previous section, we estimate the duration and intensity of pain, which I still will see in the results, I'm sure, but I still want to know how many fish and stuff they tested. Intensity of pain likely experienced during asphyxia and air by analyzing the timing of the neurophysiological processes triggered upon air exposure and evaluating the probability of different pain intensities across segments 1 through 4. As reviewed, loss of consciousness is inferred through visual and neurophysiological indicators. So basically, they had a system to basically figure out, like, okay, this fish is not conscious. Because it's not like they had eyelids to just be like, oh, they went to sleep. In trout, some data suggests that VERs are lost together with breathing and eye rolling reflexes. However, other visual indicators, such as breathing, are not correlated with loss of VERs, and are therefore poor indicators of unconsciousness. Studies show considerable variation in time to unconsciousness. So basically, they had to figure out a good way to indicate, like, okay, this fish is unconscious. We are using this method. Studies show considerable variation in time to unconsciousness. In one study, VER was lost 2.2 to 3.0 minutes and 2.6 to 3.4 minutes after air exposure at 20 degrees Celsius and 14 degrees Celsius, respectively. That's about room temperature for Americans and a little bit less. While in larger 500 G trout at 10 degrees Celsius. Loss of VOR took 17.6 plus or minus 2 minutes. For the 56% of trout that lost consciousness within the 20-minute observation period. So it seems like, yeah, putting them at lower temperatures seems to make it to where they become unconscious faster. I wonder if that means the opposite then, if you put them in like really high heats, will they lose consciousness real fast? Considering the variability of pre-solar conditions that affect time consciousness, we assume a conservative wide interval of probable durations from 2 to 25 minutes. Okay, so that's why this is such a large range, because they're basically like, the conditions are so different for, you know, probably normal processes. So I guess that's why they have such a wide range. Based on EEG observations, the declined brain signal amplitude of trout exposed to air, depression of neuronal activity, occupies the final 5 to 20% of this total time, thus lasting 0.1 to 5 minutes. The remaining 80 to 95% corresponds to segments 1 to 3. Since these segments share identical probability distributions for pain intensity, they can be analyzed as a single time period. I guess that's true. I didn't think of it in a non-study kind of way, which is important to do when doing studies, actually, of how the meat would turn out. But I guess you're right. It wouldn't be exactly good to have your fish cooked while it's still, you know, alive and then ship that out somewhere. So the probability of each pain intensity category is estimated through systematic evaluation of the evidence, summarized in Table 2. Was this a table we looked at already? Yeah, okay. With each piece of evidence rated for its consistency with the intensity criteria defined in Table 1. Oh. My playlist has potentially concluded. Let me reset that. There we go. For example, the observation of intensive aversive reactions, including vigorous movements of twisting and turning and escape attempts upon removal from water, indicates a maximal emergency response that is consistent, plus, with both disabling and excruciating pain categories. Still, the possibility of hurtful pain cannot be completely ruled out, illustrating the importance of representing this uncertainty in the analysis rather than forcing assignment to a single intensity category. Detailed justifications for ranking evidence are provided in Table S1. So basically the supplementary information. I'm not too worried about it, so I'm not gonna worry about looking through it. This probabilistic approach explicitly acknowledges both uncertainty in assessment and natural variation in how different individuals perceive the experience, when evidence suggests equal consistency with multiple categories. As in segments 1 and 3, where findings align similarly with both disabling and excruciating pain, probabilities are divided equally between them rather than forcing an arbitrary choice of one category. Okay, so if it seems like it's hard to choose whether they're going through like segment 1 of pain or like segment 3 of pain, that's why they'll divide the probabilities. So when evidence tends to favor certain categories but cannot definitively rule out others, higher probabilities are assigned to the better supported categories while maintaining non-zero probabilities for plausible alternatives. In segments 1 through 3, evidence in Table 2 is primarily consistent with disabling and excruciating pain. Let me see. No, not Table 2. I want to see Figure 2 again. Do I have that up? Nope. Oh, yes I do. Okay, so basically, it is kind of saying, like, I guess, like, the percentage of chances of the kind of pain they're feeling, if they are in this, like, level of the pain scale. Let's see, therefore, lower 20% likelihood is assigned to hurtful pain, while with the remaining 80% distributed equal between disabling and excruciating categories. This approach differs from traditional assessment methods that assign intensity or severity of a welfare harm to a single category, representing complete certainty in this assignment. Use of probability is also particularly valuable for dynamic processes where intensity changes over time. Here, evidence for segment 4 indicates a reduction in pain intensity as individuals approach unconsciousness. It's basically you being unconscious / approaching unconsciousness, you don't seem to have as much, I guess, as much of the other pain signs, I guess you can say. Since the evidence reviewed does not enable distinguishing between hurtful, annoying, and no pain during this period, each category is attributed an equal likelihood of 33%, reflecting this uncertainty. This distribution of probabilities can also be interpreted as representing the gradually reducing intensity of distress from hurtful to no pain, as the cerebrospinal fluid is acidified and neuronal activity is inhibited. While the exact probability values are necessarily subjective, it's basically saying, like, we literally could assign, like, any percentage for these. This approach provides a more realistic representation of both uncertainty in assessment and the inherent variability in perception across individuals. Cumulative pain is calculated by multiplying for each time segment in Figure 1a the probability of each pain intensity by that segment's duration, then summing across all intensities. Converting the estimates in Figure 1a into cumulative pain, Figure 1b, results in a total of 10 minutes of moderate to extreme pain per trout due to air asphyxia, corresponding to 24 minutes of intense pain per kilogram, assuming a slaughter weight of 0.2 to 1.2 kilograms. And we're finally at the discussion. Ooh. Had some big tangents in that last section, but we're here. We're doing it. So this is basically where the paper will be like, alright, we told you, like, we told you explicitly what results we got, and here's how we interpret them. So, animal welfare evaluation for decision-making in different areas requires comparable quantitative knowledge of welfare. We apply the welfare footprint framework to quantify the welfare impact of air asphyxia, a widespread practice in fisheries and aquaculture. For rainbow trout, an estimated 10 minutes of moderate to extreme full pain are endured by each trout due to air asphyxia. When standardized by production output, this corresponds to an average 24 minutes per kilogram with over 1 hour of moderate to extreme pain per kilogram in some cases. Wait, I thought they were going to talk about, maybe they will, but I thought they were going to talk about stunning methods. They didn't even get into that. They were basically just like, yeah, here's how much pain they felt. Well, let's see. Pain and distress from asphyxia in fish can be potentially mitigated by stunning methods that induce rapid loss of consciousness. For stunning to be considered humane and effective, pre-slaughter handling must be minimized and the animal must become unconscious immediately after stunning, a state that must persist until death. So basically knock them the fuck out. Couldn't you also technically just, I don't know, kind of like Calgun them, basically like stab their brains or something? Let's see. Welfare-wise, electrical and percussive stunning could potentially meet the second criterion if properly implemented. In the former case, assuming estimates of 6 cents per kilogram of trout, from 3.6 to 3.66 euro per kilogram, a 3% cost increase in ex-farm price, and 70 to 100% stunning effectiveness, this would represent approximately 60 to 1,200 minutes of moderate to extreme pain averted per dollar invested. Okay, so let me see if I can figure out the math here. It's per dollar. 100 from machines times. Okay, yeah. So that basically this calculation is how they have such a wide range of 1 hour to 20 hours of pain averted. I guess depending on like 70 to 100% stunning effectiveness, price per kilogram of fish. Okay, so it's a lot, and I don't know. Also, they didn't even really test stunning, is what I'm reading. Is they basically just were like, hey, here's how much pain they, like, all this paper studied was, here's how much pain they felt. And so that's the thing I'm talking about. Like, you look into a paper and you realize, like, oh, they actually didn't talk about, like, half the shit that's kind of, like, implied in it, or, like, around it. It's just, like, they had data for that, and then they didn't necessarily work on, like, stunning fish and talking about effectiveness of knocking them out. I mean, it seems like they extrapolated that data from other papers, but still, you know? Let's see. So anyway, let's just keep going. However, recent evidence has challenged assumptions of stunning effectiveness in commercial settings. EEG studies across multiple species have shown that electrical stunning often produces variable or insufficient stunning duration. Okay, so really pushing that point. Misstunning, or electro-immobilization without loss of consciousness. Percussion stunning, while effective when correctly positioned, still faces multiple implementation challenges in commercial settings. I have to see if one of these papers, they're just like, let's see, electrical and percussive stunning on, okay, so this paper actually cited it on rainbow trout. I just have to see if one of these, like, if one of these papers shows, I don't know, like a video like shows how they went around about those methods. No. Let's take a look. See. Because I don't know. I just think it's, again, funny. They keep referring to it as percussive. But I'm like, what? I'm like, what did you actually do, huh? Did you take like a hammer to them? What would you do to them? Like we just drop a brick on their head? What are we talking about here? It doesn't look like there's any immediate like pictures or anything. Wait, let's see. This one was killing Nile tilapia. Oh, wait. Okay, so this one actually has some good pictures. So it looks like they put some electrodes onto the fish. Okay, I think, wait, is this actually like similar to a little stun gun for a cow? It looks like they did electrical and percussive, and then also did the same thing on ice. Or maybe this one was just putting it on ice, this one was putting it on ice with electricity. Let me look real quick. Unclear baseline recordings of visually evaluated the fish was subjected to stunning protocol, followed by continuous evaluations of neurological data. Okay. Yeah, I guess. I think that's it. Here, let me show you the thing I'm basically thinking of. That's me. I specifically think of this one Sam O'Nella video that he did on the cow, the like cow farming thing.
Some are worse.
And it was using the stun gun.
I'm not a shill. Please don't get mad. And then God said, "Let there be light." And it was good.
That was not what I was thinking of. Hold on. Here we go.
A name a minute ago. In order to keep things as humane as possible, a worker will first use this device, referred to as a stunner. Here's a demonstration. This renders the beast instant.
So I'm imagining that being applied to the fish. Anyways, so percussion stunning, while effective when correctly positioned, still faces multiple implementation challenges in commercial settings, including precise positioning and strength requirements, the need for equipment calibrated to different fish sizes, and worker fatigue. In all cases, equipment failures are also an obstacle. Fair, I guess. I mean, it would work, wouldn't it? Consequently, the theoretical welfare benefits of stunning can only be realized with continued development of stunning technologies, implementation, protocols, and training. Because, like, I don't know, like, how would you do that for a wide, like, for a huge boat filled with fish or something? You know, like, do you send the water through something that should just smack the shit out of them somewhere along the way? I mean, that could potentially have been explored with the... I think they did say pharmacological methods. I think the biggest thing people would be worried about is, especially for food industry, like how much of that drug would be kept in their system, and how much would go into their food then as a result. But it sounds like they have like kind of looked at that a bit. But this is good. They are also clarifying, like, hey, you know, everything's got its kinks. Like the instruments can fail, basically. Consequently, the theoretical welfare benefits of stunning can only be realized with continued development of stunning technologies, implementation protocols, and training, and appropriate oversight to ensure consistent effectiveness across conditions. You would buy more fish knowing the drug's in the fish? I guess it would depend on the drug, wouldn't it? Several factors also suggest asphyxia in ice or chilling in ice slurry are not humane alternatives to stunning in trout and would lead to an even greater burden of pain as that estimated here. As a cold water species, adapted to temperatures as low as 4 degrees, rainbow trout are unlikely to experience rapid unconsciousness from cold exposure alone. So that's kind of true. Temperature conditions of, say, like tropical fish versus cold water species fish, like rainbow trout, would definitely give different results. Rather, these methods may introduce additional challenges: direct tissue damage from ice crystal formation, thermal shock from abrupt temperature changes, and physical pressure from ice. Moreover, by slowing down metabolic processes, lower temperatures may extend the time to unconsciousness, as already demonstrated in species such as sea bass and sea bream. So might just prolong their pain, if anything. The welfare impact and effectiveness of any stunning method also depends critically on the entire harvest process, being affected by cumulative pre-slaughter stressors. Oh God, you know, if this got out into mainstream media and stuff of all this, like, then people would have to start putting labels on things of like, our fish were killed with, you know, humane ways and whatnot. And it's always such a pain because some of that stuff is, you know, you would like to know that, but other times people will just lie about how that food is produced, you know? Or like, they'll just make shit up and it just becomes a marketing scheme, basically. So I'm through with it. I don't want any more marketing schemes for my food. There's already too much. Additionally, pre-slaughter practices, crowding, pumping, transport, are likely to represent a greater burden of pain than that estimated here, as they expose fish to multiple concurrent welfare challenges. For much longer periods, from hours to days, the WFF can also be used for assessing the welfare impacts of these processes and identifying priority areas for effective intervention. While slaughter makes up a small fraction of the life of fish, typically of 8 to 24 months in market size in the case of trout, with reforms at the farm level being more impactful, the tractability of slaughter interventions, their relevance to the scale of both aquaculture and fisheries, affecting billions of animals, is a key human intervention point, and the potential for welfare improvements make this phase critical. Estimates of cumulative pain from asphyxia provides concrete metrics for informing current policy discussions around welfare policies and industry practices at the time of killing. The finding that 70 to 100% effective stunning could potentially avert 1 to 20 hours of moderate to extreme pain per US dollar in capital costs provides producers and regulators with clear economic context for comparing welfare investments with the best benefit-cost ratio. For certification programs, these metrics enable setting evidence-based thresholds and comparing production practices. Importantly, quantitative metrics allow for clear communication of welfare impacts to both policymakers and consumers, with a measure that reflects an intrinsic aspect of animal experience, time in negative affective states. Beyond trout, this analysis provides a foundation for understanding slaughter impacts across other commercially important aquatic species. Also sounds like we're basically at the end of the article. While time to unconsciousness varies based on factors such as species-specific temperature adaptations, body size, metabolic rate, and pre-slaughter conditions, the fundamental physiological mechanisms of asphyxia-induced stress are highly conserved across vertebrates. This means the processes described and progression through acute stress, hypercapnia, metabolic exhaustion, and eventual loss of consciousness likely follow similar patterns. Providing baseline for estimating the welfare impacts of air exposure in other species, applying this baseline effectively to other aquaculture species, however, depends on species-specific data for estimating the duration and intensity of these processes, as well as an understanding of each species' responses to asphyxia. So basically, there's a lot of research that would have to go into this if we want to start humanely slaughtering fish. Notably, species adapted to hypoxic, that's true too. Any fish that are adapted to hypoxic environments are likely to show different responses than rainbow trout, a high oxygen demand species. So, like, they might not react as quick to being out of the air, or in the air, I guess, out of the water. A key limitation at present is the relative scarcity of behavioral and neurophysiological research to inform the parameters estimated here, including measurements of time to unconsciousness across a diverse range of commercially important aquatic organisms. Naturally, estimates of cumulative pain are only as accurate as current knowledge allows. This limitation is inherent to any method. However, the WFF makes the process transparent by detailing how existing evidence supports each intensity at each time segment. This transparency highlights existing knowledge gaps and allows for the incorporation of new evidence as data becomes available. So basically, this is very foundational, but it can be built upon. In summary, the WFF enabled quantifying the pain associated with the most common method of fish slaughter, one that affects billions of animals annually. These findings have immediate relevance for shaping slaughter standards and can inform decisions that must balance animal welfare, economic, and environmental considerations. Ultimately, this approach may facilitate more evidence-informed collaboration across disciplines, paramount to improve the lives of animals on a large scale. Whew, I did it. I wasn't sure if I would actually get through the whole article, but whew, we did it. So, I will say this is a relatively, I kind of want to say bare bones article. There really wasn't as much deep diving into certain things as I was hoping. I was hoping it was going to be a bit more talking about if fish feel pain, but they were kind of just like, nah, fish feel pain. And I was like, oh, well, okay, I guess I'll accept that. And I guess they feel pain with oxygen deprivation, basically, is what it tackled. And yeah, I don't know, kind of disappointed their study didn't go into like different methods of slaughter. Some basically claim that fish don't feel pain because literally how their brains are developed and how I guess like evolutionarily they're developed. Because if they straight up do not have, I forget where are pain receptors at in the brain. Okay, well, you know what I mean. The part of our brain that how do I put this? Recognizes? Okay, is that it? Thalamasses. Yeah, okay. So basically, this section of your brain is where you'd feel pain and stuff. And so, certain things, they say, like for insects, for example, or for fish, like, they might not have that part of the brain, and their bodies could just be reacting to stimuli, but they don't necessarily feel like pain, you know? Like, see, this is what their brains look like. And so, they have very obviously different brains, a lot less developed as ours. So that's the thing, is... Right, and that's the question of... Are the brains of fish actually developed enough to even feel pain? Because pain doesn't just come along with, like, you know, evolutionarily, like, kind of started around the brainstem. And that doesn't necessarily mean that, oh, they feel pain. So I think that's just been a debate of, well, they could just be reacting to, oh, I feel hot, I have to, you know, move away. So I don't know. Maybe that's been, like, confirmed at this point. Let's just say, perhaps we don't torture things, you know? Wait, what is this? Oh, little cyborg. Here, let me see if I can... So, like, brain evolution is, you know, very widespread of like, oh, we got these parts of our brains, that's why we have, like, a consciousness slash feel emotions and stuff, because that's more towards the front of the brain that's been evolved, whereas other things like fish, like, probably wouldn't really feel emotions. So it's very interesting. But yeah, so that's just a question of, like, obviously we feel pain, but that doesn't mean everything feels pain. Actually, let me see. Do insects have brains? Let me take a look. They basically just have a little, like, neuronal structure, I guess. Yeah, they have, like, optic lobes. They have... Yeah, so this is technically their brain, I guess. So I don't know, it's a very interesting field looking at neurological differences in different creatures. Yeah. But it's, you know, at least it might not be, obviously, like, human stuff is, like, the most studied things, but we have a bunch of things that, like, other stuff is studied. But yeah, it's just, like, interesting how if you go to less evolutionarily built, I guess you could say, animals, just how very simple their system is. I mean, look at their gut. It's literally a tube. It's It's straight up a tube. It's just like they eat, it goes whoop, and it's out. Whereas we have our whole, digestive system. So evolutionary changes between animals is also extremely interesting. But yeah, I guess that's more or less it. And if anything, we can take away, fish feel pain if they are taken out of water. It really fucking sucks for them. I do wonder if there's any studies of, like, even with fishing, like, if you catch and release, I guess, like, how terrible of an experience it is for them, but, give and take with, I guess, the amount of humanity that people give to things, right? Whew. All right, that was a good 2-hour stream. I have been wanting to talk about this, like, for a bit, and I keep trying to be like, ooh, I should do this after, work or something, but man, I just haven't really had the energy or time. So but I today I was like, okay, I got the time. I was like, let's do this. Well, thank you for coming. It's always good to ramble about science for a good couple of hours. And yeah, I think I like this a little bit better, of just deep diving into one subject rather than surface level of other things. So I think we'll do this more. All right. Thank you to everybody that came by today. I appreciate you. I hope everyone has a good rest of your day or night. And I will see you next time. Bye-bye.